Hello everyone, myself Dr. Kabita Sarkar, Associate Professor, Department of Mathematics, Swami, Vivekananda Institute of Science and Technology, Kolkata 145. In the last lecture, I have discussed normal distribution, PDF and properties, mean and variance. In this lecture, we are going to discuss long question answers of normal distribution. Question number 1. The weekly wage of 10,000 workers in a factory follows normal distribution with mean rupees 70 and standard deviation rupees 5. Find the expected number of workers whose weekly wages are question number 1 between rupees 66 and rupees 72. Question number 2 more than rupees 72. Given that 1 by root 2 pi integration 0 to z e power minus t square by 2 dt equals to 0.1554 or 0.2881 according as z equals to 0.4 or 0.8. This question has appeared in the MAKAUT semester exam in the year 2004, 2006, 2016. Here, mean is given as rupees 70 and standard deviation given as rupees 5. U is 70, sigma is 5, and we have to find the expected number of workers whose weekly wages are between rupees 66 and rupees 72. So we have to find probability when x less than 72 greater than 66. So we'll subtract 70 and divide by 5 less than x minus 70 divided by 5 less than 72 minus 70 divided by 5. So we'll have 70 minus 66 is minus 4, and if we divide by 5 then we will get minus 0.8, which is less than. This part we can take as z, and less than 2 by 5, that is 0.4. So this is integration minus 0.8 to 0.4 1 by square root of 2 pi e power minus t square by 2 dt. So this we can write as minus 0.820 e power minus t square by 2 dt plus 1 by 2 pi 0 to 0.4 e power minus t square by 2 dt. Now let us find the values of these two integration from the data given in the question. So look in the question, it is given that 1 by root 2 pi 0 to z e power minus t square by 2 dt equals to 0.1554 for z equals to 0.4. So it is given that 1 by square root of 2 pi integration 0 to 0.4 e power minus t square by 2 dt equals to 0.1554. Also given that 1 by root 2 pi 0 to z e power minus t square by 2. Also given that 1 by root 2 pi integration 0 to z e power minus t square by 2 dt equals to 0.2881 when z equals to 0.8. So we can write this as 1 by root over 2 pi 0 to 0.8 e power minus t square by 2 dt is 0.2881. Now here minus 0.820 and in the second integration 0 to 0.4. So the second integration is already known. This is 0.1554 and let us try to find this minus 0.820. So if we draw the number line, let's say this is 0 and this is 0.4, then obviously this is minus 0.4 and 0.8, this is 0.4 into 2. So it is double of 0.4. We can take here 0.8 and here it is minus 0.8. Now in the question it is given from 0 to 0.4, that is 0.1554 and 0 to 0.8, that is 0.2881. We have to find from minus 0.8 to 0.4. So look here from minus 0.8 to 0 is the same thing from 0 to 0.8. So we can write this value 0.2881 in place of from minus 0.8 to 0. So this is 0.2881 plus 0.1554. If we add, then we will have 5, 3, 4, 4. 0.4435. This is the required answer. Second question. Find the expected number of workers whose weekly wages are more than rupees 72. So we have to find probability for x greater than 72. We can understand by the number line, if this is x equals to 72, then the right part is x greater than 72 and the left part is x less equals to 72. So the whole part is 1. Probability of x less equals to 72 plus probability of x greater than 72 is 1. So probability of x greater than 72 is 1 minus probability of x less equals to 72. Therefore, probability of x greater than 72 is 1 minus probability of x less equals to 72. So this is 1 minus probability of x minus 70 by 5 less equals to 72 minus 70 by 5. 1 minus probability of z less equals to 2 by 5, that is 0.4. So we can write 1 by root of 2 pi integration 0 to 0.4 e power minus t square by 2 dt. So this is 1 minus 0.1554, which is given in the question. Therefore, the answer is 0.6448. This is the required answer of second question. Next question is, a fair coin is tossed 400 times using normal approximation to binomial distribution. Find the probability of obtaining heads between 190 and 210. Given that the area under standard normal curve between z equals to 0 and z equals to 0.05 is 0.0199, and between z equals to 0 and z equals to 1.05 is 0.3531. This question also appeared several times in MAKAUT semester exam. Here, the normal distribution is approximated to binomial distribution. Therefore, the mean of normal distribution is same as the mean of binomial distribution. Similarly, the variance of normal distribution is same as the variance of binomial distribution. Now, let's find the mean and variance of binomial distribution. Total number of toss given as 400 times. So n equals to 400 here, and tossing of a coin gives two outcomes, head or tail. So probability to get a head, that is small p, is half, and to get a tail is also half, that is q equals to half. As we know, p plus q is 1. Now the mean for binomial distribution is NP. So this is 400 into half, which is 200, and variance for binomial distribution is NPQ, that is 400 into half, which is 100. Now the standard deviation is square root of NPQ, square root of variance. So square root of 100, that is 10. Therefore, mean of normal distribution mu is 200 and sigma is 10. Now the mean and standard deviation known to you, you can solve the question yourself, same as before. Next lecture on exponential distribution, PDF, mean and variance.
For admission and course-related enquiry, please visit college website http://www.svist.org/